Chapter 6 is a study of random variables. In section 6.1, we'll start with the study of random variables with discrete random variables. So in statistics, we're most often interested in numerical outcomes. For example, consider tossing a fair coin 3 times, and we'll define x as the number of heads we get in those 3 tosses. And we've talked about things like this before, but we've just listed out the possible outcomes without really thinking about the number of heads or tails or whatever that we could get. So if we define x as the number of heads obtained, how many heads could we possibly get in 3 tosses? Well, if you think about that for a minute, you'll realize that you could get either 0, 1, 2, or 3 heads, and those are the only possibilities. X is an example of what we call a random variable, and that is a variable that takes on numerical values that describe the outcomes of some chance process. Discrete random variables and probability distributions and the definitions of those. So what is a discrete random variable? Well, it's denoted with a capital letter, usually an X or a Y, and it has a countable number of possible values. And that doesn't necessarily mean it's finite. There could be infinitely many possible values, but that we can count them and they're separate from each other. And so our example of tossing 3 coins is an example of a discrete random variable because there were exactly 0, 1, 2, and 3 as the possible values of x. A probability distribution is the same as what we learned in the last chapter. It lists the values of x and their probabilities. And of course, all the probabilities have to be between 0 and 1. And the sum of the probabilities has to be 1. And we learned that in the last chapter. So let's again consider tossing a fair coin 3 times, and let's define x as the number of heads obtained. What's the probability distribution for this random variable? Well, if we list out all the possible outcomes, you can see that we can get 0 heads just one way, and that's if we get tails, tails, tails. And there's the list for what if we get exactly 1 head. That head could be in one of 3 places. And there's also the choice of 3 ways to get 2 heads, and then of course just 1 way to get 3 heads altogether. So the way we will make our probability distribution is we'll write down the 3 values, 0, 1, 2, or 3, and then we'll see that there's only 1 out of 8 possible ways to get a value of 0. There's 3 out of 8 possible outcomes, ways to get 1 head, and then there's 3 out of 8 possibilities for getting 2 heads, and just 1 out of 8 ways of getting 3 heads. We could also construct a probability histogram for this, and it would look exactly like you would expect. We will put the values of x on the x-axis and then their probabilities on the y-axis and make a histogram of that. And we'll describe this. I'll talk about this more just momentarily, but we'll talk about this being symmetric and single-peaked. We'll talk about where the center is, maybe about at 1.5, and then we'll also want to talk about what the standard deviation of this distribution is. So we'll talk about the mean of a discrete random variable first. So the mean of any discrete random variable is an average of the possible outcomes, but it's weighted by the probability because some outcomes are more likely than others. So let's describe our discrete random variable as having values x sub 1, x sub 2, x sub 3, and then corresponding probabilities p sub 1, p sub 2, and p sub 3, and so on. So to find the mean, or the expected value is just another name for the same exact thing of mean, we multiply each possible value by its probability and then add all the products. And the formula looks like this. The E of x here stands for expected value, And you can see that we're just taking the value of x times its probability, plus the next value of x times its probability, and so on. Don't forget that the sigma here means sum of, so we're just adding the sum of the products of the values of x and their corresponding probabilities. We'll do an example just shortly. And then the standard deviation of a discrete random variable. We'll start with the variance. This is just like we did back in chapter 1, I guess it was, when we were doing the mean and standard deviation of just a single variable, and we had to find the variance first. So here's the formula for the variance. You take each value of x, you subtract the mean, and you square it, and then you multiply by the corresponding probability. Next value of x minus the mean, you square it, and multiply times its corresponding probability. And again, here's our sum of individual values of x minus the mean square times corresponding probabilities. And of course, to get the standard deviation of the random variable, we take the square root of that variance. So the standard deviation will be the square root of the sum of the individual values of x minus the mean squared times individual probabilities. That's all under the square root. This formula, along with the formula for the mean, is on your formula sheet, so you won't have to memorize that. So let's do an example. Let's go back to our random variable of tossing a fair coin 3 times and counting the number of heads that we get when we do that. So if I want to calculate the mean for this, it'll be the individual values of x, so starting with 0, times its probability, plus 1 times its probability, plus 2 times its probability, and then 3 times its probability. If you multiply that all together, you'll see that you get, and then add, you'll get 12/8, or 1.5. And if you'll recall from the probability histogram, we could see that the mean of that distribution was at 1.5, so that makes sense. Now keep in mind, you will not want to round this. I know we can't get exactly 1.5 heads, but this just says on average, if we do this many, many, many times, we'll get an average of 1.5 heads on the tosses. For the standard deviation, I like to just go ahead and put a big square root. So it's the square root of the individual value minus the mean, which is 1.5 squared, times an 8, plus the next value of the variable minus the mean squared, and then 2 minus the mean squared times the probability, and then plus 3 minus the mean squared times its probability. And just type that all in your calculator, and you should see that the standard deviation is 0.866. Now I know you're thinking, well, what if I have more values of x than that? This can get really, really long, and yes, it can. Your calculator can do this. I'll just give you a hint now, and you can see if you can figure it out. But what you'll do is enter the value into a list and the probability into the list on your calculator, and then when you do one variable stats on that, there's a little field that's called frequency. And in the frequency, it currently has 1 for that, but you'll put the probability there. And so what will happen is it'll weight those values of x that you put in one list with the corresponding probabilities. So what I've asked you to do, just to make this a little more simple, I think, or I hope, is I've given you an example here that's at the bottom of your notes page. And I've asked you 3 questions here, and I'm going to put these on a Blackboard quiz as well, but I'd like for you to, since you'll need your calculator, I would like for you to work them out separately, and then just type in the answers that you get onto your calculator. Be sure to round to 3 decimal places, so hopefully if we're all getting the same answers, it will just show up one time for that. So good luck with that, and I'll see you tomorrow.